It's the 8th of April 2025. I have to use the phone to do this. I have a newspaper there for clarity, but what I'm trying to show you, and I hope it comes out. I'm trying to get a peep in to see if it is coming out. Is a brazed joint. Now you see there, what I'm trying to do there, and I have a newspaper there so you can see it, is the two pieces of steel coming round there and joined together needed something a bit more solid. And so I've brazed on two thick pieces of, like big thick washers, or even washers would do. I brazed them on using brass brazing. And they're brazed onto mild steel bar. Okay, so now we try and get that stopped. Now here is a bleed off from a fuel tank of a tractor where the outlet got damaged. See it there? Again, it's very hard to get it right. I showed you this before, and it's joined there. It's already in the tank. So it's joined roughly here, right there, okay? Now, again, it's the 8th of April 2025. And what I did there earlier, and I may never show this video unless it came out right, is I've showed you the application of brass brazing and silver soldering. Now, for those who don't know, this is vintage. If you're not into this type of thing, then don't watch it, because my channel is more or less based on ordinary working people's hobbies, activities, and making a living, and to try and learn from my mistakes. I do not see any advantage in me keeping secrets and bringing them with me to the next world if I can't share them here. Now, so we're looking at metal joining. So what you saw there in the first clip was where I attached two thick washers turned on the lathe to a mild steel bar. So here is a mild steel bar. This is a standard bar, right? Buy it anywhere, any hardware mostly. And you see a hole in the end. And in that case, I needed to join this with a bolt to another steel bar. And so this area here is the weak part. You see it here. That and that are weak. That's what that'll break if it comes under strain. So I needed to attach a ring, a 1/4 inch ring around it. And that means that it's all attached here. When the pressure comes on it, it's all one part. So I brazed on the two rings. Now, if you go to weld them with an electric arc welder, a stick welder, or any other kind of welder, you're weakening the material. Everything's very light. And so brazing is ideal. So for that, you see now what I'm talking about. That's mild steel bar. It's quite thin. What is it? 3 mil, let's say, 4 mil. So the real old system was brass, welding with brass, hence the name brazing. And it has quite a high melting point. And you can get it here. Here's a brass rod. You need to label them. You need to plain brass. You need to label them. This is brass rod. And that has quite a high melting point. But it's below the melting point of the mild steel I've shown you. Now, with that brass, you need a flux. General brazing flux. It's a white powder. Now, there are health warnings on it. It say about it that it can cause problems. But it's generally used. Any problems is not going to affect the vintage man too much. But for someone doing it all the time, a proper respirator designed for the stuff that's in that and the fumes would be good. Also, brass contains zinc. And zinc, when melted or burnt, gives off a toxic gas. I think it's zinc oxide, but it's a gas anyway. Now, for the like of this, it's not much. If there's any little bit of ventilation blowing away from you, then you're safe. If you're welding outdoors and you're upwind of it, you're safe enough, it'll carry it away. But just be aware of zinc, and even welding farm building equipment that's zinc coated, that's galvanized. Just be aware of that. Having your head down and breathing it big time is not good. A lot of this industrially is done in a fume hood. But brass is safe enough, in my opinion, and I'm only giving this as my considered opinion. Go with the safety experts and the warnings on it. Brass is all right to use. Where brass brazing comes into problems is, and long ago they used to smelt it in furnaces. So there was all of that. But the thing about brass is, when you melt it and get it up to the melted point, you need to do whatever you're doing and let it cool. It's only when you reheat and reheat and reheat that the galvanized begins to give off fumes. Again, you're talking to a lay person, a farmer with cows, doing the best he can. I've been doing this for years, but just be aware that there are fumes from galvanized. Okay. Now, so this is a great strong joint, and in what I've shown you out there with the newspaper behind it, that's an example of where brass brazing is almost as strong and probably stronger as electric arc welding. Now, then there's another product called bronze. And bronze, this is an example of one here that got damaged. Bronze brazing is copper and tin, and in my opinion has a slightly higher melting point. So again, whether brass or bronze, they have a high melting point. I find it harder to use than brass, but it gives a nicer surface. And the professionals all say brass is good for hooking about. It doesn't give such a good surface. It doesn't give such a good finish. Although it's used in bicycle frames by highly professional brazers. This has flux on it. You can have the two fluxes. Now, can I just deal with the subject of flux? This particular, here's one here. You see the coat on it, and this is what it gets like. It breaks off a lot, but if you're using it, it's very hard to keep it in touch. Well, this one here has no flux. What I use is the flux, and these will do, or just this alone. But you need to have flux ready in case it wears off this. Now, if you are brazing something light, copper or stainless steel, you have the problem of the parent metal, as they call it, the parent metal, getting too hot. You also remember, if you're brazing copper, there are copper solders which contain phosphorus, which they claim need no flux at all. I haven't tried them. I might try them another time. The copper, whatever's in the copper, welding copper to copper when it has a certain type of rod, I'm not going to go there for the minute, doesn't need flux. However, if you look at all the joints you buy in the plumbers, they all have flux into them, and those the material there usually is copper and tin and maybe some other alloy, bismuth or something else, to bring down the melting point so that the copper is not burned. So a big problem with brazing and welding is not to damage the parent metal. In welding, you always damage the parent metal. It doesn't matter whether it's gas or electric, or the forge. The blacksmith's forge was welding. The whole idea is that you make the two welds join. They're all the same substance. So either in blacksmith's forge you join wrought iron to wrought iron using sand and flux. They needed flux. You couldn't blacksmith or weld without flux. In modern times, you use a filler rod, like a welding rod, of the same steel, and you melt it. And only oxygen and acetylene will get the temperature up enough to weld steel. Only. You cannot do it with any other material, including propane. Now, I come very near to doing it a few times with light material, but you need acetylene for that. So here is a piece of an old washing machine. It's stainless steel, and I'd done some experiments with it, and I found the problem when I went to use brass or bronze. The problem I found was that the stainless steel got too hot, and in some cases you can actually see here where I nearly almost came through, but it didn't actually come through. The melting point of this stuff is about 200 degrees, I would say. Sorry, 2000 degrees, maybe 1900 to 2000. Don't hold me on it, right? Stainless steel is ordinary steel containing chromium. It's a wonderful piece of equipment. Now, in the video, I'm after showing you of the brazed joint. I use brass for that purpose to braze the piece of mild steel bar that I've shown you there. In the case of the joint on the tank, I used 55% silver solder. With delicate joints for stainless or anything else, where the pressure is not fantastically strong, where it's not really brutal, where you're not putting a big bolt on it and hammering it, by going high silver, you get a better joint, better capillary action, and better sealing. So you get what you pay for. But you don't need silver solder for joining a piece of an iron bar to a washer. You don't need that. You're better off using brass if you can get away with it, and get it up to a real high temperature till it's almost at kindling temperature. It goes to glow a little bit yellow, and get your bar in and get it melted. And I've given you the example there, and there are numerous videos online about welding bicycle frames. Okay, so that's to understand that you need to assess what you're going to do and have the tools for it. So this is stainless steel, and the problem is when you put the gas on this, it gets too hot, and you can't get your brass rod up to the temperature, or your, what do you call it, bronze or brass, up to the temperature. By the time you get this here hot, this is mad hot, and it's beginning nearly to melt. It's hard to get this to do it. So the problem is that this is too thin in section. Do you see? It's too thin. So what I've done was I've done a few tests. So here is a piece of raw brass which did work. Here is a piece of raw brass which did work. So it can be done. Here is a piece which did it. But you see the way it's a lump. Do you see the way it's a mound? It didn't melt right because I couldn't get the heat hot enough to make it melt, and it tended to burn off even the flux. So here is another example, proving that you can weld with brass to this stuff, but it's difficult to do. Now, here's an example here where it didn't work. It ran off it like a bubble. It's difficult. Here's an example here where it did stick. Look at that, it stuck to it tight, but it's a lump. Because I couldn't get the temperature of this high enough without melting this here with oxypropane. In all cases, what I'm showing you here is oxypropane. All cases. Propane uses more oxygen, but sure, you only have to buy the oxygen. You have it simple. You can buy the propane anywhere. It works good enough in most cases, except for certain delicate cases and jewellery where acetylene is still the king. Now, here is an example of a 31% silver, right? You can buy silver solder from Johnson Matthey in Dublin, from Oxyarc in Dundalk, and there are several other suppliers. So you see the way the silver solder adhered there? It's stuck to it. So when you go up in the silver, you get a lower melting point and you get a good job joint on light stainless steel. Have I explained that fairly well? You see the problem I have here? I couldn't get this to go down because the heat was so hot it was nearly melting away the flux, and it ended up in a bubble. Whereas when I added a piece of silver to a 31% here, it worked better. So the trick of it is to know what amount of silver you need in your rod. And of course, silver is expensive, and it's a pity to use it and waste it and not throw it out. You know, it's a pity, really. It can't be recycled. So I only use silver where I have no option. If it's a big rough job, I use bronze or brass. heat her up to blazes. Okay? Now, there was a time when I wrongly believed that I had to use an ordinary torch. There's three types of torches. There's the benzomatic or the MAP gas one. You can buy them in any hardware shop. They're not too bad. If the thing is heavy metal, you need even more. The other one is the Bullfinch torch, which are advertised. They work off the propane cylinder and they use the oxygen from the air. They're pretty good. You see, with a lot of work, you can preheat with ordinary air oxygen and then use your oxyacetylene to get the final braze done. Right? But I was wrong. I could have been in ahead of them with the propane air torch, but you couldn't get oxygen either, except a big rental whillabaloo. Life wasn't worth living with them, and rental agreements, and you nearly had to sign your life away. So now Hobbywell came on the scene as I was building this machine here, and Hobbywell, I have to recommend them. They've worked well. You pay a bit of a deposit and you get your cylinders, and you could get away with Hobbywell with oxygen only and use your propane gas. And an awful lot of metal cutters and scrap yards and that are doing that. You use a bit more oxygen, surely. You need 3 times the oxygen. But you don't need any acetylene. And you don't have any of the snags that come with acetylene. You can't turn an acetylene cylinder on its side and use it. The acetylene cylinder is not vacant inside. It's full of a honeycomb type of filler. And then the acetylene is dissolved in acetone. So it's a big thing, but it's very, very useful. Now, here is a project I had, and it's still work in progress. This is a little gas cylinder. And I want to put an acetylene generator in here. And this is calcium carbide, sent over by the Royal Mail. And there's a group in England doing that. A mineral water or something, water mineral or something. I can't think of the name. And just see what's inside it. Comes like this. Okay. Carbide. And it's not cheap. Minerals water unit, I think it's 6. It looks like Orwell Lodge, Fairview Industrial Estate. I can't actually see. Rainham, England, obviously. Anyway, that's it. It can be got online, and it's quite expensive. It's quite expensive. Now, the idea I had was that it could be used in here as an acetylene generator, and you drop it. I had to find a way to get it in, and then it had put water in here, and it give off acetylene. And I made a crude one of these years ago, and it would work. The problem I had with this was it was leaking. You see, this is all welded with rod welded. See there, electric arc, round here. And then you'll get little leaks. So then you have to grind down, you have to put it into water, and you have to pump air in here like a tyre of a car. You have to pump air, and then you'll see the little holes, and then you have to braze. And you have to braze with brass starting off, and that takes quite a good deal of fuel and oxygen. And then when you have that sealed, you blow it again, you'll find a little leak somewhere else, and you have to use a lower melting point, maybe 31% silver. And then when you come down to the final one, you can use, for small little holes, you can use 56% silver, let's say, or maybe 45, 31, 45, 65. Then you're down to ordinary lead tin solder, salt solder, to fill up the final holes. And in fact, chemical metal might work as well. When you have all done, then a bit of chemical metal on the inside tends to work, or some type of sealant. So that's the idea with this. Is still a work in progress. So that's an idea of using electric arc welding first for the strength, because when that's going, there's a nice bit of pressure on it, and then you use the brazing or the brazing with either brass or bronze, and then you use progressive amounts of silver to get it done at a lower temperature, and then you might move on to soft solder. So it depends on the application. But that heavy cylinder, and don't forget, I made sure it was full of water before I took it to the angle with the angle grinder to it. That heavy cylinder will absorb a lot of heat. It's doubtful if any torch would do it, even the benzomatic or the silvered. But you won't be doing that too often, so you have to walk before you crawl. Now there's a group, Johnson Matthey does silver solder, and there's a group called here called Coop Alloys, and they're in United Kingdom, Mansfield, Plessy, Mansfield, and they will, I don't know, will they send it to the south? I'm not sure. You can email them. But if you want to drop a line to Valmart and Kingsford, I would be able to find out where you could get small things. I don't like to be promoting any kind of cross-border trade, but maybe a few little things that I could help bringing in the like of that stuff and get it in through the north, which is handy for a small fee somebody pays up there. But anyway, so now there was another man doing it free, but he closed up. So then they sell you Flux for the lower melting point for their particular silver solders. So here's EF Flux in a small amount here. EF Flux. Where's the thing here? Where's the? Oh, here it's here. EF Flux, and then they use this other one here, H5. Now the H5 is for the lower silver solder silver content. It's for higher temperature, because they supply the model engineering thing for making copper boilers. And so you start off with a copper boiler with high melting point, and you go down then, because if you use a high melting point for secondary or third brazing, you could melt the original. You don't want that. So this would be a small amount and for a high melting point, and this here would be a low melting point. And then here is a little piece I got. This is this is 55%. They put 4 before everything. 455 means 55%. 431 it'd be 33%. So you see there, that's a little roll. That's all you get, see, of high silver solder. So that would be used for delicate matters. You would not use that to braze a big lump of a nut on an old bar of mild steel and a half rusty. That's for delicate work. Okay, you'll get that done all with a torch without oxygen cylinder. You'll get that done. So they'll post it over to you in small amounts. Now, one of the things I must do is save little, what do you call them? Little plastic containers, and put it in. Or a big one and pop that in and take it out as you need it. And it'll last a while. And you're as well off buying small amounts and use it as you're going. So I think I've explained a bit about that. So that the hobby man doesn't have to learn all himself. I have books on it here too, very good. It's our Model Engineer's Handbook. I'll again show you some of the books I have. I don't think I have them here. Anyway, there's a guy called Tubal Cain. It's only a pet name. It's not his own name. He's Bradshaw, I think is his name. So this is a cutting torch for oxy or propane oxygen. Oxy, propane, or oxyacetylene. They call it oxy fuel. And this here is for cutting. So what happens is there's two different types of nozzle. There's a different nozzle for propane than there is for acetylene. So what happens here is you get it up to the kindling temperature till it's almost yellow, and you have to have eye protection and really good goggles for this. You'd really want a shade, I'd say shade 8 anyway by right. You only need about shade 5 for silver soldering, for normal work. And then when you get this at the edge, you put the thing at the edge. When you have this at the edge, you press this button here, and that lets go the oxygen. And it's the oxygen does the cutting. Cuts away the steel. Now, really, in the age of the angle grinder, there's an awful lot of videos about cutting, except for industrial use or A breaker's yard. I don't know, do you ever need that at all? I don't know, do you ever need that at all? Here is a tip of a retiring person gave me his set, and there's a good tip. That's a big tip there now, and so that's the type of tip you would use for most brazing. So have I explained all that? I think I have. If the original clips don't come out, I have to scrap all this again, because this phone will not let me trim videos. So that's all. That just came in a packet like that. The whole, we'll just see how much now. That's 2 little things of Flux and 1 of silver solder. And I'll just read you the prices in UK sterling. Flux 540, Flux 630, that's the H5, and the brazing wire is 719, and then there's VAT on that, 375, so it's 22.57 for those 2 pieces of Flux and a little bit of silver solder. But once you get the trick of it, and once you get in, it's like learning to ride a bike. You have it for life. And I would suggest that parents who have young lads, or even girls, should teach them this. I see a lot of women now in the farm services and the selling mechanical parts and selling tools. And you know, I really would love to get in front of a class with them and explain all this in my head. There should be more teaching. I learned a lot of this at Carrickmacross Vocational School in Ireland. And I was using a lathe in that school at 16 years of age, a Colchester student. I think that's where we're missing. And you see now, they're realising that the importance of making your own stuff in your own country. And we don't have the skills. Not every young lad and every woman is into that. You need a certain type of hand on you. You need to be able to steer, you know. You need a cool hand, and you need to go. See, some people wouldn't see the point. When you get into it then, and I personally, I can know, you know, I know that I can braze that with brass. But I can't braze, I can't braze this with brass here. You see. So I hope that's some good. You cut your cloth according to your measure, as to say. It is a fascinating hobby. I didn't go as far as to say I'm a bit addicted to it. It's nearly a compulsive disorder with me, but it's very, very enjoyable. And when you get out into that workshop, there's nowhere like it. You know, it's really fun making things and making mistakes and sharing. And that's the thing about the men's shed in Ireland. That's what I joined the local men's shed here, and I had to leave because it was all talking, and it was all taken over by the local councillors, and it was all rigged, the whole thing. It wasn't up to purpose like everything the state does. So some men's sheds are good, but I won't get into that here. Anyway, that's the story now for you folks about joining metal. You can weld with a stick welder, you can weld with TIG, which means there's a tungsten tip, and with TIG you need a shielding gas. You use a rod. So you use a rod with TIG. So it's very like oxyacetylene or oxypropane. But with the other one, it's argon gas. With the other one, MIG welding, there's a coil of steel wire, and it comes out as you're using it. So it's a slightly better system. But for me, and from knocking about the farm, the old stick welder will do me good enough if you really get to understand it and get to know the right size of rods to use and the right settings, and even maybe sometimes if you have heat system, preheating your work. It depends on what you're doing it for. If it's big awkward steel, and I did all the internal steel on my cattle shed, except I didn't do the building of the shed now, not the roof or the uprights. I did all the internal steel works. I used a lot of steel, and it has been hugely successful, medium in a shed, and a bit of wood as well, which is very unorthodox. I didn't use all concrete. And it has worked fairly good. So, right, that's the story. I don't know will this ever produce a settling. Sometime when I get time, maybe. But this is the point about getting alternative electricity sources and that. I don't want that. I don't want to be bothered my head supply electricity to my neighbour. I want to supply it to myself and get it supplied to me at a reasonable cost. That's good enough for me, and get on with some better things to do. All right. The way this works is it's bolted down on a flat top. And then all the equipment is meant to go in here. And these side holes here are meant for having a stirrer, that you can put an O-ring and stir the mixture here, and there's another one here for a fuel gauge, you see, for a pressure gauge, and this here is for the takeoff. So this is the idea. It's a terrible disease. Vintage and workshop stuff. It's a disease. You'll never have a bit of comfort. The only thing for a partner, when he's out in the garage doing this, you know where he is. And he's not gambling and he's not drinking, and he might produce something good at the end of the day. Or indeed, there's no reason why women don't do it as well. Generally speaking, they don't do it. They do jewellery and that sort of stuff, but they still use these. Some women make jewellery at home. And if you had good hands on you and you're a woman, you'd get a little Hobbywell oxyacetylene system, or even oxypropane, quite small, and you could do jewellery, but you need to know what you're doing. You probably need a course on it. And in jewellery, the silver solder, you can't really use salt solder to break. You're dealing with precious metals, and you have to have the exact right solder. So, for example, like I'd say now for jewellery, and I'm not too well up on this, I won't be making jewellery because I haven't time, but I'd say like a silicate that you'd be using, you know, little tip of that, and you'd have a tiny little torch, just a tiny torch. You can get them, and you'd be getting that right, and that would turn out beautiful earrings, gold, different colours of gold, silver, platinum. These metals are dear, but they're not that dear, you know. But if you're dealing with a little gold wing on a bird, you've got to make sure you don't waste, you can't overheat, you have to get it right. Just think of all those skills that a person could develop, or a young lady could develop if she's starting out in the world and get into that. She's not bothering anybody, and she could produce her own line of jewellery there, and it could be absolutely beautiful. You know, it's like baking your own bread. These skills will not go away. You will not make jewellery too easily by machine. And anyway, the whole idea of a jewellery is it's unique. So you could guarantee that nobody else will have these earrings. There could be two little birds, and nobody else will have these earrings because you've made them, and you won't be making the next one the same. Just ideas of idea. Okay, folks, I hope you enjoyed that. I hope nobody looked at it unless they're interested in it. And we'll see you back for something else. It's Tuesday morning. It's time to get out on the trail, as to say, and put this to effect. Bye bye. See you back soon. Thank you.